Okay, before leaving today, I wanted to do another video to show you how to do the multiplication of two numbers, at least one of them being negative. We already saw in class that for numbers that were represented in sign and magnitude, the only thing to do was to do the regular multiplication with positive number for the two magnitude and then to figure out what the sign was. So we'll not be dealing with that further. We will assume here that numbers are provided to us in two's complement whenever those numbers are negative. So let's go. I like to do as usual to take example to do that on the base of an example. Let's say we like to multiply the number. I'll take 37 here by 29. So we have a little bit of work to do here, and then we set 39 to be negative. Yeah, let's go. The representation of 39 is 32 plus 5. So which means that the lower three digit will be 5, and then 32 will count up to 5. 1 2 3 4 1 2 3 4, and then 5 here. So we put a 1 in front to state that it's a negative number, and that here is the number 37. So what is minus 37? We flip 1 0 1 1 0 1, and then 0, and adding a 1 to that gives us the 1 0 1 1 0 1 1, and this here is the minus 37. So what is the number 29? 29 is also 24 plus 5. So we'll do 24 plus 5. Let's start with the 5 0 1 0, and then 24 is 16 plus 8. So we're gonna have a 1 here and then a 1 there. Because the number is positive, we have a 0 in front. Like we saw in the last video, we don't have to have exactly the same number of bit here as here. So they can have different number of bit, and then since we're multiplying, since this here, the lower number is our multiplier, we're gonna have 1 2 3 4 5 6 7 6 steps to go. Okay, so let's clean a little bit up and then put the number that we like to. Oh my god, what did I do? Yeah, this oh yeah, I have to wait to restore. Okay, so 37 minus is I'll put it here. Our x is 37 minus a 1 0 1 1 0, and then 1 and 1 on 7 position, and then y is equal 0 1 1 1 0 1. So let's make a bit of room to do multiplication. Now our multiplication, we have the c, the p, and then we have the y. C start with the 0, p we have 7 position to represent the p. We have 0 0 0 0 0 0, that's 6, and then 0 is 7. So let's push the y a bit further. So y, we start with the number 29, which is 0 1 1 1, and then 0 and 1. Now first iteration, we look at this number and put here iteration 1. The y0 is equal 1, then we'll add x. Adding x, meaning we take the value of x, which is 1 0 1 1 0 1 1, and then the result is 1 0 1 1 0 1 1, and then we bring this down 0 1 1 1 and 0 1. So to complete the first step, we need to do a shift, and this shift to the right lead to the 1 goes here, the 1, then the 1, pardon, goes there, the 0 goes here, then the 1, then the 1, and then the 0, then the 1, and here the 1, the 0, the 1, 1, 1, and here the 0. So the uppermost position, this position, we filled that with a 1 here because we had the sign of the number being 1. So we're doing an arithmetic shift there. Now our second iteration, we check the value here, which is 0. So second iteration, y0 is equal 0. We'll just shift. So just shifting will give us the 1, 1, 1, 0, 1, 1, 0, and here 1, 1, 0, 1, 1, 1. So the third iteration, y0 is equal 1, we'll add. So we add the value of x, which is 1, 0, 1, 1, 0, 1, 1. And the result is the 1, 0, 0, 0, 1, 0, 1, and then 1. Am I correct? 1, 0, 0, 0, 1, 0, and then yes. And now we bring this value down 1, 1, 0, 1, 1, 1. So to complete the third iteration, we need to shift. And then shifting gives us the value of 1, 1, and then 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, and 1. So now we start in the fourth iteration. Fourth iteration, we check y0, which is this value, is equal 1, we will add. And then adding is, here we add the value of 1, 0, 1, 1, and then 1, 0, and then 1, 1. So gives the 1, 1, 0, 0, 0, 0, and here the 1, and there the 1. And here we bring 1, 1, 1, 0, 1, 1 down. So to complete the fourth iteration, we shift to the right, and it gives us here the 1, 1, 0, 0, 0, 0, 1, and here the 1, 1, 1, 1, and then the 1, how many 1? 1, 2, 3, 4, 1, 2, 3, 4, 5. No, we're getting a 0 here, and then the 1, 1, 2, 3, 4, 5, 6, yes, 0, and then the 1. Okay, so we're doing our fifth iteration, y0, this value here is equal 1, we will add, gives us here the 1, 0, 1, 1, 0, 1, 1, and then adding 0, 0, 1, 1, 1, 1, 0, and then 1. And I'll bring this here down 1, 1, 1, 1, 0, 1. And now we have, that was the shift, that was the addition. So we need to shift now to complete our fifth iteration. Shifting will give us the 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1, and then 0. And then 0. Okay, so with that, we're starting the sixth and last iteration. Sixth iteration, y0 is equal 0. We'll just shift, and then shifting will give us a 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1. So this is our final result. And this final result, which number does this here represent? Like I said in class, to find that out, because this is a negative number as expressed by this sign here, we can find the 2's complement of the number, and then in order to find the corresponding number, what's the 2's complement? I'll flip the bit here 0, 0, 1 there, 0, 0, 0, and here 0, and here 1 and 1, and here 0, 0, 0, and 0. Adding a 1 to that will give me the 0, 0, 1, 0, 0, 0, 0, 1, 1, 0, 0, 0, 1. So what is this number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 2 to the 10. 1, 2, 3, 4, 5. This is 2 to the 5, and this is 2 to the 4, and this is 1, 2 to the 0. So 2 to the 10 corresponds to 1024. 2 to the 5 corresponds to 32. 2 to the 4, 16, and then 1. So this number is 1024. So 1024 plus 32 plus 16 plus 1. So 6 plus 4 to 10, that's 3 here, and remaining 1, 3, 3, 7. So the number here is 1073, which means that our final result here must be minus 1073. So what do I get? Let me check that using my calculator here. I'll plug the number 29, or let's say 30, 37, multiply by 29. Yes, I get exactly 1073. So this is the final result. Okay, so what have we done? Again, to summarize what we've done, we always take the dual multiplication by looking for each iteration the last digit here of the multiplier. If that is a 1, then we will add the multiplicand to the partial sum, and then we'll shift the result one. The result is provided here, and then we shift the result one position to the right. This is what we're doing for positive number. Now, because our multiplicand is a negative number, as seen with the 1 here in front, when we do the shift, the right shift, so shifting, and then the leftmost position here will fill that with the 1 to preserve the sign of the result. And we do that, how many steps we do that? The corresponding number of steps is the width of this multiplier. Our multiplier has 1, 2, 3, 4, 5, 6 bits. That's why we went first iteration, second iteration, third iteration, fourth iteration, fifth iteration, and sixth iteration. In every iteration, whenever the least significant digit, which is y0, is equal 1, we add the multiplicand to the partial sum that we already built here, and then we shift one position to the right in order to complete that iteration. If the number is 0, if the last significant digit here, the y0, is equal 0, we just shift. That corresponds to adding a 0 and then shifting. So instead of wasting time adding a 0, we could just go ahead and then shift that. So with this, we know how to do a multiplication of two numbers. our multiplicand being a negative number represented in 2's complement. Okay, thank you.